Hello, good morning, everyone. We are going to kind of jump back on track, which is we're going to talk about solving some more quadratics. Yesterday, like that exponential, nope, start over. That square root thing that we were simplifying is kind of a weird spot, but you're going to kind of see where it comes in today. So we're going to solve some simple quadratics. So let's say something like 3x squared plus 2 equals, I don't know what it equals, 11. All right, when we talk about simple quadratics, typically what we're going to talk about here is the ones that don't have a b term. So notice we have an a term because we have an x squared. There's no x term here, but we still have that constant at the end. Or we don't have to have that constant. The c term doesn't really matter, but it doesn't have a b term. If it has an x squared and an x, we're going to have to do something else. Either factor or what we're going to kind of continue to talk about the rest of this week and next week. But from here, since it doesn't have that x term, we're going to kind of think about solving this normally, just like you would a two-step equation. So here's my x. I want to get it by itself. We're still going to kind of do the same idea. So we're going to subtract this 2 from both sides. That's going to give me 3x squared equals 9. And then, just like before, we want to get rid of this 3. So we're going to divide by 3. Divide by 3. And x squared equals 3. But my last step is now something with an x squared, right? And so this is where the tie-in comes in, because now if we want to get rid of something that's x squared, we have to square root. That's the inverse operation. A root gets rid of an exponent gets rid of a root. So to get rid of squared, we need a square root both sides. And so the solutions here are going to be the plus or minus square root of 3. Now, we're not going to write the decimal equivalency because now we know about breaking down square roots. So square root of 3 is not going to break down, but if it did, we would break it down from here and simplify all of our stuff. Important to note, we have to make sure that we write both of our answers, plus and minus, square root of 3, because we know it's going to have two solutions because of the fundamental theorem of algebra, of course, which says that since this is x squared, it could have up to 2 solutions. And that's pretty much it, except for obviously breaking down the square root if I need to. Let's do a different one. Let's say we got 2 x squared minus 9 equals 31. Okay. So I want to get x by itself here. Same idea. Well, this brown marker, not the best marker, I would say. So I want to get rid of this minus 9, so we'll go ahead and do that. Add 9 to both sides. So 2x squared equals 40. And then again, we're going to get rid of the coefficient first, so divide by 2. We get x squared equals 20. And then to get rid of the squared part, we're going to do our old friend, the square root. But this time we get square root of 20. And I know for a fact that square root of 20 is going to be one that breaks down, right? Because it has the perfect square 4 in it. I can write it as 4 times 5. So if I pull this 4 out, the square root of 4 is plus or minus 2. And we still have that square root of 5. So really, this is the reason why we learned about that square root thing here. I guess why your book thought it was important here. Because our answer is going to be some sort of square root, and we can pull it out. So we know that the answer to this solution is positive 2 square root of 5 and negative 2 square root of 5. Yeah, it's not so bad, really. It's pretty easy. Basically, you're just using those algebra skills. The only thing that's different is at the end, we're throwing that square root in to get rid of the x squared part, and then using your skills that we've been working on the last few days anyway. Yeah, I could do like 10 more, but I think that that's probably okay. Let me know if you guys have any problems or anything. I think it's pretty easy, and you guys will be all right with this. So we'll probably just do one day, and then talk about completing the square on Friday, which is a little bit more tricky than this, but that's okay. All right, almost the weekend. We're almost there. Woo!